All right, welcome everybody. We're just going to wait a couple more minutes here for some other people who have registered for their webinar to come and join us. But thank you for being here. We're going to get started here in just a minute. All right, we'll probably wait one more minute and then we'll get started. All right, we'll go ahead and get started here. Welcome everybody. Thank you for joining us. My name is Michael. I'll be your host for today. If you don't know me, I'm a cloud solutions architect from Massdriver. Massdriver is a visual internal developer platform that enables engineers and developers to deploy production-ready infrastructure and applications in minutes. Today, we'll be making AKS easy using the Massdriver platform. However, I do want to note that the knowledge gained from this webinar regarding AKS can also be applied to EKS and GKE for Amazon and Google, respectively. During the webinar, members of my team at Massdriver will be in the chat answering any and all questions. Let's go ahead and get started. So for this webinar, we're going to cover the following topics. We're going to talk about some of the basics of AKS. I'm going to go over how to connect to AKS using the Kubernetes command line tool, aka kubectl. I'll then deploy an application to AKS using Massdriver, and then we'll end on discussing different options for scaling and monitoring AKS. Before we get started on the basics, let's briefly talk about some of the terminology that we'll be using during the webinar. We want to make sure that everybody's on the same page here. While it's not vital to learn this terminology, it can certainly help diagnose and fix issues if you understand some of the basic components of Kubernetes. So let's start with a pod. A pod is the smallest and most basic deployable unit in Kubernetes. It can host one or multiple containers, and containers within the same pod share the same IP address, port space, and storage, allowing them to communicate easily with each other. A pod represents a single instance of a running process in a cluster. A service in Kubernetes is an abstract representation of a set of pods and a policy to access them, usually implemented as a load balancer. Services allow for the decoupling of pod endpoints from consumers, which is especially useful since pods can be dynamically created and destroyed. This means that if the individual pod IP address changes, the service ensures a reliable way to access the application hosted on those pods. Namespaces are a way to divide cluster resources between multiple users or teams. They provide scope for names, allowing multiple teams to use the same resource names without conflict. Namespaces are especially useful in large clusters to provide a level of isolation and organization, ensuring resources are separated and grouped logically. So now that we've covered some of the basic terminology we should know, let's go over some of the basics of AKS specifically. The basics. Okay, so Kubernetes in Azure is not the same experience as you would have with a standalone Kubernetes cluster. Azure assumes responsibility for managing some of the components of AKS for you. So let's break it down each component here quickly. This diagram is showing a single AKS cluster. We have the cluster master that is managed by Azure, and then we have the nodes, which are managed by the user. Let's talk about the cluster master first. So the cluster master, also known as the control plane or the master node, is responsible for cluster management and providing the API that is used to configure and manage resources within the cluster. The Kube API server exposes the Kubernetes API and validates and configures data for the API objects, which includes pods, services, and replication controllers. The API server is the front end for the Kubernetes control plane. It provides the interaction for management tools such as kubectl or the Kubernetes dashboard. The kube scheduler is a control plane component that watches for newly created pods with no assigned node and then selects a node for them to run on. When you create or scale applications, the scheduler is what determines what nodes can run the workloads and then starts up those nodes. etcd is the consistent and highly available key value store that is used to maintain the state of your Kubernetes cluster and configuration. It can also hold small amounts of data that fit entirely into memory. The Kube Controller Manager oversees a number of smaller controllers that perform actions such as replicating pods or handling node operations. There are many different types of controllers, such as a node controller that is responsible for watching nodes and responding to one if it goes down, or a job controller that watches for these one-off tasks and then creates a pod to run those tasks to completion. Those are just a couple of examples of those controllers. So now we have the nodes. To run your applications and supporting services on AKS, you need a Kubernetes node. A node is essentially a virtual machine. It contains all of the services needed to run the VM, the containers to run your application, and then some other components that we'll touch on. The node also allows you to define the amount of CPUs, memory, size, and storage type to use. The VM image is also run on the node level, allowing operating systems like Linux or Windows Server. We also have a concept of node groups or node pools, depending on which cloud you're referring to. Regardless of the terminology you want to use, they serve the same purpose, which defines a group of nodes within the cluster that all have the same configuration. The kubelet is the Kubernetes agent that runs on each node in the cluster and processes the orchestration requests from the control plane, along with scheduling and running the requested containers. On a basic level, it makes sure that containers are running in your pod. The kube proxy handles virtual networking on each node. The proxy routes network traffic and manages IP addressing for services and pods. The container runtime is a fundamental component that allows containerized applications to run and interact with additional resources, such as the virtual network and the storage. It is also responsible for managing the execution and lifecycle of containers within Kubernetes. And then last but not least, we have containers. So containers are a packaging of applications and execution environments. Containers can resemble virtual machines in some ways, each with its own CPU share, memory, file system, etc. However, Kubernetes containers are considered lightweight because they share the operating system and other components with other containers in the pod. Now, you might be asking yourself, what is the difference between a pod and a container? That's actually a pretty good question. It's important to know that pods are composed of one or more containers, so the container actually resides within the pod. Okay, so now that we've covered some of the basics of AKS, the components, let's go over this Kubernetes command line tool. Some people refer to it as kubectl or kubectl, or even just kubectl. There is no one way to say it. It simply stands for Kubernetes command line tool. It's mainly used for communicating with the Kubernetes control plane using the Kubernetes API. Let's dive a bit into the Kubernetes command line tool, but first we need a config file. I'm going to switch over to Massdriver to get my config file. So to use kubectl, we first need to fetch this config file. Within Massdriver, what I can do is I can hover over this box on the right-hand side. Now we see this little window pop up, and it's allowing me to download a raw JSON file that contains information needed to connect to the cluster from a resources perspective. Now, we technically could use this JSON file to create a config file, but this webinar isn't called AKS Made Tedious. It's called AKS Made Easy, and we make this easy for you. So this drop down, let me bring this up again. This drop down on the right-hand side for more options, I can select kubeconfig, and then I can click kubeconfig to download it. So now I have this kubeconfig file here sitting in my file explorer. Now that it's downloaded, I'm going to go ahead and rename it to config.yaml, or just call it config. It's already a YAML file. So we're going to call this config, and then I'm going to go ahead and move it into my WSL environment. Oh, Michael, we're going to drop it into my .kube folder. Here it is, and I'll just go ahead and paste it in here. So we have a config file in my .kube folder. In my WSL environment, it might look different to you, whether you're using Mac OS or strictly Windows. And then now that it's downloaded and moved over into the folder, I need to set the environment variable in my terminal. So here's my terminal. I'm in my AKS Made Easy directory. All I'm going to do is run export kubeconfig, all caps, is equal to the directory for the file. So export kubeconfig is equal to the path of where I can find this YAML file, and then enter. So I can test my config file with a simple command, kubectl get pods. And I'm actually seeing no resources found in the default namespace. That's okay. Even if no pods return, the Kubernetes API is still responding to me. If it wasn't, I would see an error message like couldn't get server API, group list, connection refused, something like that. But now that I know my config is correct, I can communicate with my AKS cluster. There are all sorts of commands that I can run. I'm going to go through a few basic ones and talk about each. So we're just going to go ahead and clear here. I can do kubectl get config view. So kubectl config view will show you the cluster that you're managing while redacting your secrets, which is actually pretty nice. So if you're ever not sure of which Kubernetes cluster you're talking to, you can run kubectl config view, and I can see here AKS made webinar. This is the name of my AKS cluster, and then this is the full API URL that it's using. I can run, let's see. So I have a container file. I have a Mongo container file, which allows me to manually deploy something into Kubernetes. I can manually deploy this Mongo image that I have using this container file. And I'm using a command called apply. It's going to look like this. So I'm going to do kubectl apply -f, and then the route or the path to the containers, and then Mongo. So the route to the file. And we're going to apply that. So it's telling me pod Mongo created. So now if I do kubectl get pods again, we'll see that the Mongo container is actually being created as we speak. So I just deployed an image to my Kubernetes cluster using this apply command. And I'll be able to do that. I'll be able to use this pod a little bit down the road. I'm going to cat this file so you guys can take a look of what this YAML file looks like while this container is creating. So containers Mongo. And as we can see, it's just a real simple YAML file. It's setting some metadata for the Mongo pod that I want, and then it's setting the image of Mongo, naming it Mongo. I'm basically getting a very basic down and dirty Mongo image from Docker up and running in Kubernetes. Okay, so now that we see, let's do kubectl get pods. My Mongo pod is up and running. I'm going to switch to some other commands here. So we can view our available namespaces, as we talked about namespaces earlier, a way to organize and segregate different aspects of your cluster. So we have numerous namespaces here available. The MD core services and the MD observability are created by Massdriver. Core services contain services like cert manager, ingress controller, external DNS, Prometheus. Prometheus is an MD observability. So we have these different services that we provide out of the box for you from Massdriver. I can actually do kubectl get pods -- namespace MD core services. And this will allow me to see the pods that are up and running in another namespace. So this is important for figuring out what might be going wrong with your AKS cluster while you're troubleshooting it. So we have a list of pods from the MD core services namespace. Like I said before, namespaces provide scope and grouping. So to view the pods in other namespaces, you need to specify them. We can also look at the logs of pods. If I do kubectl logs, let's do this cert manager pod here. So I'm going to put in the name, and then I have to specify the namespace. And we can see a list of logs that gets populated from that particular pod, which is helpful for troubleshooting. I can also use a describe command. So a describe command will tell me the status of something. So we can do kubectl describe pod Mongo, because I have the Mongo pod in the default namespace. And I'll minimize this a little bit. So we can see this is actually describing my entire pod. It's giving me the entire status of what's going on, the IP address, recent events, conditions, what volumes it's using, the container metadata, stuff like that. So all very helpful in troubleshooting. Now we can also look at deployments. We can do kubectl get deployments, and then we're going to do namespace MD core services. So we can look at what's actually been deployed into our Kubernetes cluster using the deployments lookup. Lists all of the deployments of the MD core services with this particular command. This will be helpful with troubleshooting a couple errors that we'll discuss in a little bit. We can also run explain. Explain is really helpful because it gives you the API docs right in the command line tool. Let's do kubectl explain services, and I'll make this a little bit bigger. And now I have an output of an API doc that tells me what a service is and the different fields that are available with it. Really nice for learning Kubernetes and figuring out what I'm doing. We have an exec command. Exec will sort of like remote into the container, like you can do with a VM using a bash shell. We can do kubectl exec -it, select the Mongo as the Mongo pod that's going to be exec. We're going to do -- bash. So this is going to specify I'm execing into the container, specifying the container itself, and then I'm specifying a bash shell. So now I'm actually in the container. If I do mongo d - version, we'll see, Mongo, the image is returning that image version. I can go ahead and exit. And then the last one that I want to cover quickly is kubectl API resources. So this lists all of the resources in the cluster that the cluster can manage. And this is very helpful for troubleshooting as well. So namespace, the kind of API resource that's in there, the short name, and the version. There are many other commands available to use within the Kubernetes command line tool. I'm going to go ahead and post a link in the chat to a cheat sheet if anybody's interested to sort of help you get started with using kubectl. So now that we covered some of the basic commands, let's go ahead and move on and talk about running an application on AKS. So because this is Massdriver, we're going to do it the easy Massdriver way. I'm going to make an application template. Let's go ahead and clear my terminal here. In my current directory, if I do ls, we can see it's empty. So I'm going to run mass bundle new using our Massdriver CLI tool. This will generate some application templates for me. I'm going to go ahead and name my template AKS made easy. I'm making AKS easy. So I set a description, and now I select an application template. So these are the runtimes. We have several runtimes available within Azure. Some are serverless, some are Kubernetes specific. I'm going to select Kubernetes deployment because I want my application just deployed onto Kubernetes. Now, we also have a long list of dependencies to select from. Again, some are cloud specific, some are not. And this list is updated quite frequently. So if your application requires any specific dependencies, you can add those here. Because my application is just a very simple one for this webinar, I don't need any dependencies, so I'm going to select none. And then the output directory, I'm just going to put it into the root directory here. Now if I do ls, we'll see some files here. Excellent. Now I'm just going to publish my bundle at this point. Normally what I would do as a developer is I would go into this massdriver.yaml file. I would make some updates, adding environment variables, secrets, IAM policies, stuff like that. But because I don't need that for my demo, I'm just going to skip it. If you'd like a more in-depth look at customizing your application template before publishing it to Massdriver, I'm going to post a link to one of our previous webinars where we dive deep into the application template. So we're going to send that over right now. So the next thing I want to do is just run mass bundle publish. And it's going to publish it to my canvas. So now let's switch over to Massdriver. If I refresh here, we should see my AKS made easy app. Oh, there it is, right at the top. I'm going to go ahead and drag it out. We'll call this AKS made easy. AKS made easy, and click submit. Our infrastructure generator tool will connect everything up for me. And there we go. So now I'm going to go ahead and configure my application. All I'm going to do is use a basic Nginx image to confirm that my application is working. We'll assign some resources, very minimal. I don't need a lot for an Nginx image. We'll support the 8080. Open up public internet access, and let's do nginx.md spx.com and deploy. Okay, so this should take no more than 3 minutes to come up. While we are waiting, I did want to mention that we do have a community Slack available for anyone who's interested. I'll go ahead and post a link to that in the chat as well. So the community Slack, this is a rapid growing community. filled with engineers, developers, enthusiasts, who are all using Massdriver for their production environments, their ephemeral environments, even side projects. We are more than happy to have you in there. I'm in there, other members of my team, pretty much my entire company is in the community Slack. Feel free to pop in and say hello. We'll also be at AWS reInvent this year from November 27th to December 1st. We do have a booth. So if you're going to be at reInvent 2, please feel free to stop by and say hello. We'll be giving out some sweet swag, as well as hosting some events throughout the week. I'll be there as well. So I really hope to see you there. And then just need another minute while this finishes deploying. If you haven't visited our YouTube channel yet, I hope that you do. We're building a library of great content to help newcomers and veterans integrate Massdriver into your daily operations. I'll go ahead and post a link to that YouTube channel here as well. Now we just need to wait for one more minute for this application to finish deploying. And then what we're going to do from there is we're going to test the application, and then we'll move on to talk about scaling and monitoring AKS. Now, one thing that I can show you while we're waiting here is if you were to go and configure and deploy AKS into the Azure portal, if you haven't done it before, it's kind of confusing. It's complicated. There's lots of options to choose from. And if you're not familiar with AKS or Kubernetes in general, most of the time you have no idea what options you're selecting. In Massdriver, AKS made easy. We also make deploying AKS easy. Clicking on the configure button of AKS, this is the configuration page for AKS. You select the version, which may or may not be sticking around. We might be doing auto upgrade soon. You select the compute size for your node group. Select minimum and maximum instances. Enable controller, ingress controller if you want. If you do, you can add your DNS zone. That's it. That's all you need to do to deploy production-ready AKS in Massdriver. So now my application is done. It's deployed. Let's confirm that it's working. I'm going to take the URL here and open up a new tab. And now I have this Nginx 502 gateway error, which is actually what I would expect by running an Nginx image. So this is great. I can confirm that it's working. So let's talk about scaling and monitoring in AKS. I'm going to switch over my presentation here. So to scale, actually I can keep back into Massdriver. Sorry about that. To scale AKS, we have a few options. We have the node group compute size. So I'm going to click configure on AKS one more time, and then we can see the compute size here. We have a drop down of varying options. We can change the compute size of AKS to scale. Now, doing so will delete the node group and recreate it. It's actually not that big of a deal in AKS. AKS is smart enough to use temporary names so that there are no conflicts when it recreates the node group. We can also set a minimum and maximum number of instances in the node group because the AKS will use the cluster autoscaler by default. It is enabled. It watches for pods in your cluster that can't be scheduled because of resource constraints. And then when the cluster autoscaler detects these issues, it scales up the number of nodes in the node group to meet the application demand. It also checks for nodes lacking, or for a lack of running pods It also checks for nodes for a lack of running pods and then scales down the number of nodes as needed. Now, that's all within AKS. We also have some scaling options within our application. If I click configure on the application and scroll down a bit, we have horizontal pod autoscaling. So the horizontal pod autoscaler, if I click to enable here, it's also available within the application template. The horizontal pod autoscaler, or HPA, uses the metric server in the Kubernetes cluster to monitor the resource demand of pods. If an application needs more resources, then the number of pods is automatically increased in a horizontal way to meet that demand. And of course, you can set the minimum and the maximum number, and you can even set the CPU, target CPU, for what triggers a horizontal scale out. So that option is available as well. If you disable HPA, you can just statically set the number of replicas to constantly maintain, regardless of resource utilization. So those 4 options are available for scaling. All right, so to monitor AKS, we actually build that into the platform for you. The green clouds on each of my resources signify alarms. By clicking on the green cloud on AKS, I can see 5 different metrics that we're tracking to alarm on. These are monitoring all of the pre-installed apps that come with AKS, such as Cert Manager, External DNS, Ingress Controller, Prometheus, etc. On my Kubernetes app, we can see 3 more metrics that are more specific to the application itself. So what do these alarms mean specifically? I'm going to break down each one of them for you. Let's go ahead and switch. Okay, so these are the alarms that I'm going to break down pretty quickly, and I'll also give you sort of like a head start on what to check if you experience this alarm. So deployment rollout successful. This ensures that the most recent configuration has been successfully rolled out to all of the pods running in deployments. This alert would trigger if that was not successful, in which case you would want to run a describe on the failed deployment. So you can do that using kubectl get deployments and specifying the namespace for like empty core services or wherever it is. And then you can use kubectl describe deployment name and then specify the namespace. Pods ready. This checks to make sure that all pods have passed all ready health checks and will alarm if a pod has failed the ready health check. You can find out which pod isn't ready by using kubectl get pods and then kubectl describe pod with the pod name. And that will show you the recent events as we saw earlier. Pods crash looping. This alarm triggers if a pod has entered the crash loop backoff state, where it is continuously crashing after it starts up. You'll need to dig into the pod logs to find out what's causing this, and you can do that with kubectl logs pod name. Daemon set rollout successful. This is pretty much the same as the deployment rollout alarm, where it ensures you have the most recent configurations, except this is for daemon sets. So you can use kubectl get daemon sets and specify the namespace to get a list of the daemon sets, and then kubectl describe daemon set with the daemon set name and specifying the namespace to determine what's going on there. And then last but not least, autoscaler unscheduled pods. So this alarm triggers if there are pods that are unscheduled, aka cannot be placed, and the cluster autoscaler cannot resolve it by scaling up. So it may not be possible for the cluster autoscaler to scale up for a number of reasons. It could be because the node groups are at max scale already. That's a possibility. Or the pod requirements don't fit any of the pods that the autoscaler can resolve. Another potential issue is the pod is asking for too many resources. There are other potential issues. The best way to determine what the issue is for this one is to run kubectl get pods to list all of your pods, and then kubectl describe pod with a pod name to find out what happened with that one unscheduled pod. So the cool thing about Massdriver is that whenever an alarm is triggered, let me switch back to Massdriver real quick. Whenever an alarm is triggered, this green cloud here will actually turn red. And then the actual alert within the list of alerts will turn red. In addition to that, Massdriver will send you emails and they'll say, hey, John, your AKS cluster in X project in your Y environment is having an alarm for autoscaler unscheduled pods. So this tells me exactly what the issue is, which one of my resources having that issue, and I can take that information without even having to log into Massdriver, and I can go and start troubleshooting based on the information that I learned. When that alarm is resolved, the red cloud will turn green again. The state of the world will be happy. And I'll also get an email, a follow-up email saying, hey, John, your AKS cluster X project Y environment has resolved its alarm. Good. I'm happy with that result. All right. Let's go ahead and switch back to the presentation. So it's time to recap. To recap, we covered some standard Kubernetes terminology and then did a high-level overview of different components of AKS. We then dove into the Kubernetes command line tool a bit, learned about some of the more common commands you can use to poke your way around a Kubernetes cluster. We then created an application template for Kubernetes and deployed it onto AKS using Massdriver. We spoke about scaling and how that works with AKS, using Massdriver specifically. We then finished up talking about monitoring and alarms, what some of the alarms might mean, and then the first place you should check when you see those alarms. This concludes our webinar. Thank you so much for joining us today. I'll give you the remaining 24 minutes back for your day, but thank you very much for joining us. My team and myself will be sticking around to answer any all questions. If you're interested in learning more about Massdriver, please check out massdriver.cloud. You also may email me directly, michael@massdriver.cloud. And then we also have a link there in the presentation if you want to schedule a demo to check out Massdriver. All right, thank you.